Hello, everybody. Welcome to Con 205. My name is Akshay Ram. I'm a product manager at AWS. I'm super excited to talk about AWS App Runner today. I'm going to be joined by Noam and Sahar, both of which who have worked with Wix and Wix's use case on AWS App Runner. So let's get started. For the agenda for today, we're going to talk about why we built AWS App Runner. We're going to do a little bit of the origin of species as to how we evolved and learned from different products and why App Runner, why we specifically built App Runner. We're going to take a look at some of the use cases which are actually a good fit for AWS App Runner. We're going to take a look at some of the benefits that you get when using the service. I'm going to go through a demo, and I'm super excited to show and use the product live, so you can see what the product is in a more by seeing the console interface. I'm going to take a look at some of the recent App Runner launches, and then I'm going to hand it over to Noam and Sahar at Wix, who's going to talk to you about Wix's use case on App Runner. So, what is AWS App Runner? AWS App Runner, at our very core, we want to improve developer productivity. And how we're making a dent in this space is by building a really abstracted service for running web applications and APIs. We heard from customers saying that, hey, there's so much of our business logic packaged as web applications and APIs. Can you give us a service in AWS that is turnkey to run these applications? And that's exactly what AWS App Runner is. If you take a look at a web application, there's a lot of moving parts to run some scalable and secure web applications in the cloud. For instance, if you were to see some sort of reference architecture, the parts you'd see is a virtual machine, of course. You'd see layers of software in the virtual machine. The OS, OS could be something like Amazon Linux, language runtime could be Node or Python. And your application itself, here's where your business logic of your application sits. You want to have multiple copies of your virtual machine for redundancy and usually spread across multiple availability zones. You want to have a load balancer in front of these virtual machines to balance your incoming traffic amongst different replicas of your application. You want to have auto-scaling set up such that when you're seeing more demand to your web application, you're able to scale in and out and respond to demand. And when there's periods of inactivity, you want to scale in as well for cost efficiency. And you want to set up a CI/CD pipeline such that you can incrementally deliver new versions of your software over time. Given that this is a typical reference architecture, there are three ways you can operate this on AWS. This slide basically divides the responsibility into two. There's an AWS responsibility and a customer responsibility. AWS responsibility is below the line, and it usually means AWS is managing and operating the infrastructure components. Customer responsibility is above the line, the dotted line you see there, and that's where customers are responsible for maintaining and managing the infrastructure. So when you're operating web applications on EC2 instances, AWS, of course, manages the physical server and the hypervisor, but you get a lot of control. You get to manage the EC2 instances. You can choose amongst the numerous EC2 instance types. You get to manage all the layers of software that go into your EC2 instance. You get to manage a load balancer where you have control over custom routing rules. You get to manage application auto-scaling, and you get to manage and set up your own CI/CD pipeline by using a service like CodeDeploy or a partner tool like Jenkins. Also, all of these infrastructure resources are in your account as a customer, so you pay for these resources separately. So if what I mean by that is if you go to your AWS bill, you'd see a line item for the AWS load balancer, you see a line item for the EC2 instances. So all of these infrastructure resources are provisioned piecemeal. So operated this way, customers have a lot of control over their infrastructure. But there were a segment of customers who said, I don't need this level of control. I want an interface that's focused more on my applications, and I want AWS to manage some of the infrastructure for me. So more than a decade ago, we built this service called AWS Elastic Beanstalk. What AWS Elastic Beanstalk gives you is an interface really focused on applications where you just give us your applications package as source code. And Beanstalk will actually orchestrate all the moving parts behind the scenes, be it the load balancer, be it auto scaling, be it your EC2 instances with managed updates, or even your CI/CD pipeline. So this gives customers a very application-centric view of operating web applications in AWS. And many customers use Beanstalk and are happy with Beanstalk. But since these infrastructure resources are again provisioned in your account, you do pay for them piecemeal. And what we heard from a segment of customers is, hey, Beanstalk is great. It gives us this application-focused interface. But what if I don't have any infrastructure resource in my application? What if my primitive to operate on AWS App Runner is an application itself and all of the infrastructure is fully managed or serverless? And that's where AWS App Runner comes in. So we learned from building over a decade of developer-focused interfaces. We combined it with modern serverless technology with ECS and Fargate. And what that gives you is a fully managed service to run web applications. As you can see, the AWS responsibility is a lot more here. We manage the containers underneath and the language runtimes. All of that is fully managed. We manage the load balancers. We manage auto scaling. We manage CI/CD pipeline. And when I say manage, these are turnkey features you get on the service. You don't have to add on any infrastructure components. It's just a feature. And the primitive you operate on AWS App Runner are just web apps. And since you're only operating web apps, you only pay for these applications. And we also built a pricing model with AWS App Runner where your pay scales based on the number of requests that are being processed by your application. So you have that value-based pricing as well that goes along with your applications. So to summarize, App Runner is our learnings from over a decade of building developer-focused experiences on Elastic Beanstalk, combined with a really modern serverless technology with ECS and Fargate, to give you a service which is really optimized to run web applications and APIs, of course. What are some of the use cases with AWS and App Runner? We see plenty of customers running front-end and back-end applications, and a front-end could be something like Next.js. Back-end can be Express or Flask. That's pretty common on App Runner. We see customers running their back-end services for their mobile app, be it an Android app or an iOS app. There are back-end services that are running on App Runner that serve a function which services the mobile app. We see with containers, plenty of customers split their business logic and functions into microservices. And that helps us really, we've seen plenty of customers operate small HTTPS request response based microservice applications. We see that on App Runner today. We see plenty of language selection and diversity. For instance, we see Node, we see Python. App Runner also supports container images, so you can come with Ruby on Rails, you can use Java. So there's a lot of different languages and frameworks around the web applications, which we see on AWS App Runner today for use cases as we just discussed. So we've taken a look at why we built App Runner. We've taken a look at some of the use cases. Now let's take a look at some of the benefits. You'll hear me say this a lot: increased productivity. So we really want customers to operate at that application level while we take all the undifferentiated heavy lifting that comes with operating a web application and the infrastructure operating the web application. So you focus on apps, not infrastructure. With App Runner, you get a lot of built-in features, and one of those features which customers really like is built-in deployments. So all deployments on App Runner are blue-green by default. You don't have to set up any additional infrastructure. It's just a feature. So it's just a default feature. You get automatic scaling. So we heard from customers that a lot of services that are easy to use don't scale well as their businesses grow. We took that feedback and make sure that App Runner can scale really well and responsive to your incoming traffic. So the service has really responsive automatic scaling. We have isolation by design. App Runner is built on AWS Fargate, a serverless container technology here at AWS. And what Fargate does, it isolates every container with a virtual machine boundary. So you get that inherited property on AWS App Runner as well. You have integrated observability, all the logs and metrics you need to operate a web application, you just get out of the box with AWS App Runner. And you have really granular pricing. See, we want customers to pay when their web applications are serving traffic and generating business value. So we've built our pricing model and our cost allocation for you to easily track and monitor that. Now that we've taken a look at some of the benefits, I want to take you through a demo to bring some of these benefits to life. For the demo specifically, I'm going to walk through 4 scenarios. I'm going to deploy an application live, and just to show you how easy it is to get an application up and running. While the application is deploying, I'm going to walk you through some additional configurations so that you can see, if you need to tweak certain knobs, what are those knobs? I'm going to walk you through some of the built-in observability features on how you can operate your web applications. And finally, I'm just going to close the loop by talking through cost allocation and pricing to see how you can optimize your applications once they're running on AWS App Runner. So I'm going to switch to my console screen right now. So this is the AWS App Runner. As you can see, it's there in my console. I'm just going to click through to it. And the first portion of the demo is I'm going to create a service live. So I'm just going to hit create service. I'm going to zoom in a little bit to ensure you can see clearly. So the first fork in the road while creating your service with App Runner is telling us how your application or your web application is packaged. Is it a container or is it directly from source code? App Runner accepts both. If you're using source code, of course, you can just directly link to your source code on GitHub and we will fetch it for you. But if you're using containers, you can package your web application as your container and host it on ECR or ECR public, both of which are supported on AWS App Runner. For the purposes of this demo, I'm just going to choose ECR public. I already have an application up and running, I already have an image uploaded. This is the image I'm going to use. It's essentially our demo App Runner application. So I'm just going to reference that URL. You have 2 deployment options. It's very simple. Both deployment options, as I said in the benefits, are safe by default. It's blue-green. The only difference between the 2 is manual mode is when you choose when you want to deploy a new version of your service. Automatic mode is when App Runner will detect that there's a new version of source code at this registry, and it'll deploy a new version for you automatically. So it helps in cases when you're doing rapid iteration and development. I'm going to hit next. I'm going to call this my app for reinvent. I know it's a long name, but just bear with me. You can define the amount of compute a specific application instance needs. For now, I'm just going to keep it at 1 vCPU, 2 gigabytes. You can, of course, configure this. You can add some environment variables, just as you would in your desktop. But this particular application doesn't need any environment variables. You tell us which port your web application is running on, and this is essentially using port 8000, as you can see here. The port here is port 8000, so I'm just going to enter 8000. There's a bunch of optional settings here. These are completely optional, so I will walk you through them later. But for now, I'm just going to hit next. I review everything. Everything looks good, checks out. And that's it. I hit create and deploy, and App Runner will go ahead and deploy a web application for you and make everything ready. And when it's ready, it's going to be deployed against this URL. So this is the HTTPS endpoint. App Runner is HTTPS by default, where it will start serving requests. Of course, you can add a custom domain if you want, if you don't want the default App Runner URL. Now that I've deployed a service and the service is currently being deployed, I'm going to walk you through some additional configuration. The second portion of the demo, as I discussed. So in additional configuration, you can, of course, edit your source code. I think I showed you the source code already. You have ECR and ECR public. I'm not going to change any, or using source code through GitHub. I'm not going to change any of that. You have additional settings such as auto scaling. Auto scaling is interesting. I want to spend a minute here. Auto scaling, we scale based on the number of concurrent requests that are sent to your application. So if you have, by default, it's 100. You can, of course, increase or decrease this. And if you need more, so no two requests are the same. So hence, you want to tune this variable based on your application load pattern. And what App Runner will see is whenever your concurrency value is hit, it will add a new application instance to start processing requests. So it'll scale out horizontally based on this threshold, and you can define this threshold. You can, of course, specify a min and a max size. A use case for something like a max size would be, hey, I want this is my dev app, and I want cost control here. So I want to set a max limit so I don't have runaway scaling or some problems. You can specify health checks. As I said, we do blue-green deployments. If you want more control over the deployments by saying, hey, only pass the deployment if it passes health check against this route path and against certain thresholds, those are knobs you have here, and it's completely tweakable. You have certain security options. For instance, there's an IAM role called the instance role. And the instance role essentially enables your application running on App Runner to talk to other AWS services. For instance, your web app needs to talk to DynamoDB, which is a database. You can totally do that. And what the instance role helps is you don't have to bake the AWS IAM credentials into your application. You can instead use the instance role to hold the credentials. And it's very common to it's very similar to an EC2 instance role, or if you've used ECS, a task role. So that's what an instance role does. You, of course, have encryption by default with an AWS managed keys. You can specify your own KMS keys if you need to. And of course, there's tags, and tags really help you in your cost allocation and your granularity in cost allocation, as you'll see later on. Given that we've seen some of the additional configurations, I'm going to walk you through the third part of the demo, which is the observability. So in the observability section, you have logs and metrics. First, I'll start with logs. There are 3 log streams here. There's event log, deployment logs, and application logs. Event logs are basically logs emitted by App Runner, the service, as we're deploying your service. As you can see here, we're starting to create your service. We're moving through steps in the assembly line of getting your service deployed. So you can see all of those events. We're currently health checking your application. So it gives you like this under the hood status updates. As you saw, it also passed the health check. So it seems to be almost done with preparing your application. There is deployment logs. Deployment logs are not that helpful for container images, but if you're using source code, you can see us installing pip install requirements.txt. All your dependencies being installed will be shown here. So it's helpful for customers who use source code. And finally, application logs. These are the logs that are actually sent by a web server. And as you can see, the server is up and running, and it seems to be already serving requests. As you can see, the service is already created, but before I actually hit the endpoint, I also want to show you the metrics. In metrics, you have a lot of application-focused metrics. The request counts that are sent to your application, your 2xx, 4xx, 5xx, request latency, of course. So very application-focused metrics. And you also see active instances, which is essentially gives you a measure of scale activity of how App Runner is scaling based on your incoming requests. So given we saw all the observability, I'm just going to hit the endpoint now, just to show you that the application is up and running. And as you can see, we just deployed a live application here in App Runner in a few clicks and walk through all the configurations, and it's super simple. Finally, the last portion of this demo, I want to show you how the cost allocation and visibility works, because it's really a game changer, because you get unit economics by default. And I'll show you what I mean by that. So I'm just going to go to the AWS Cost Explorer. I'm going to a service. I'm just going to say AWS App Runner here. I'm just going to hit AWS App Runner. And I've tagged a specific service. So I'm just going to click on App Runner environment. Production. This is a tag I've added to one specific application running on App Runner, so I can see that. I'm just going to seek to a particular time interval where I actually sent the application a lot of traffic. And I'm going to switch to the daily view. And I'm going to sort it by pricing dimension. I know I clicked a lot. I'm just going to take a step to explain what I did here. So I said, hey, what are my costs associated with AWS App Runner? In AWS App Runner, I want to know the unit economics of a particular app. So I filtered by a specific tag. And as you can see here, I get my daily costs. And also I see that during some days, my costs are higher than others. And this is basically based on incoming requests. So during these days from June 4th to 7th, I sent the application with a lot of traffic. App Runner charges you for vCPU only when your application is processing requests. As I said, we had request-based pricing. When your application is not processing requests, we scale all the way down. So you're not charged for vCPU. We just hold on to your application's memory. And we do that for latency reasons. We heard from customers they don't want cold start. So you get consistently low millisecond latency with App Runner. And you pay a very low nominal fee. For instance, memory is 1/10 the cost of vCPU. So you get that low cost savings as well. So that concludes the demo. We essentially explored how to easily deploy an application and how to measure value of running an App Runner with the Cost Explorer. So I'm going to switch back to my presentation to take a look at our recent launches. Some of the recent launches on AWS App Runner is AWS CDK L2 construct. So CDK allows you to compose infrastructure as code using a programming language of your choice. So that's easily possible to do with App Runner today, where you can compose App Runner along with a database, for instance, RDS or DynamoDB. We launched App Runner Enhanced Logging and Monitoring. This is a continuous improvement process to help our developers be more productive. It's something which we're always going to enhance. We launched IDE support with VS Code and JetBrains, where you have a one-click, hey, I'm running my app, and just click to deploy to App Runner, and you can one-click deploy from your IDE all the way to AWS Cloud. We also launched a one-click integration with ECR Public. ECR Public is a service where you can upload container images, and publishers upload common container images, for instance, Nginx. So you can explore the Nginx image, hit a button, and it'll deploy it on App Runner to kind of try the software before you want to incorporate it in your setup. So now that we've seen the recent launches, we've seen the demo, and we've also seen why we built App Runner with the benefits, I'm going to hand it over to Noam at Wix, who's going to talk about how Wix uses App Runner today.
Thank you, Akshay. Hello, everyone. My name is Noam. I've been working in Wix for the last 9 years. But first, before we start to present everything, I want to say a few words about Wix. Wix is a platform in which small, medium businesses can easily create their website and manage their business. Wix started about 15 years ago, and today it serves over 250 million users in 100 countries and employ over 5,000 people. But today we're not going to talk about Wix. We're going to talk about a product within Wix, which is Velo. And Velo is a development platform Wix offers to combine two different worlds, web development and web design. We want to allow the designer to design a beautiful website and the developer to build the backend rapidly with least amount of DevOps and maintenance. So the first point I want to emphasize about Velo is that it's not a low-code platform in which the developer just configure parameters and receive a very limited website, because those platforms does not expose the cloud to the developers. We are developing our own private cloud for our customers. In Velo, each project has its own Node.js integrated database. We are exposing all of the services within Wix as an API and supply proper UI elements for the developer. With this, the developer can edit everything in our built-in editor, and all is needed for the developer is just to press publish, and the site and backend is available instantly. We also want the developer to handle the least amount of DevOps to start and stop services or allocating resources. We want our developers not to be bothered by that. But I mentioned earlier that we want to be, and we are a development platform and not just a tool. So the developer in this case always asks to bring his own infrastructure. And we listen to those requirements. And the first infra we're allowing to fully replace is the database. Why do we first decided to expose the database? Why is the data so important? One of the first point and key elements that our customer comes to us is the ownership of the data. Data is the most important asset. We can replace the servers, we can replace the technology, but the data is the only constant and important thing that we want to hold on to. As a developer, I know that there are many types of database solutions, and the reason that they still exist and there isn't just one database that we all use is because each data store has a specific use case that it fits. Some scenarios works really well for relational databases, while others really fits NoSQL or document store. Wix data that we give to the customers has limitations, and because we developed a solution, we can't support everything. So if someone needs something right now, he or she may have an option to develop it by themselves. And the last point is that the last point that I want to emphasize is that all customers has their own special and unique requirements. Sometimes they need their database to sit in a specific location. Sometimes they're just interested in a specific and a specific technology, a specific product. For this, we allow them to use their own database. So now that we discussed the why, let's look at how we're planning to do that. So let's first understand currently the architecture that we have on Wix infrastructure. So if you had a Wix site and now you want to add logic to it, you will add your app on top of the Velo infrastructure. The Velo infrastructure gives you a Node.js server, but also it gives you, through Wix data, your own managed database. All of this is part of the app, and all of this is being managed by Wix. So the user doesn't have to set up servers or anything else. To edit the site and the app, it is using the Wix editor. And we also expose some management tools and logs and statistics to our infrastructure, so the user will be able to know when what is happening within the database or the application server. And now let's look at what we're going to do. So we added a new creature called the Velo adapter, which we talk to using our SPI. It's a regular Node.js application that will drill into it a little bit later. That Velo adapter is the one that translates the database that we're adding to the SPI that's being needed by Wix data. The database that's being added is basically any database, and we support various products right now. And all of those machines and services, they are all managed and handled by the customers. Also the customer is the one who's paying for them. So once if this is the architecture, let's drill down into the customer site and understand what's the requirement that we had in order to build that. So since the app is going to be deployed on the customer cloud, it must be fully transparent. So we open source the project and we give the customer a Docker file on a public repo that is ready to deploy. Nobody wants to run some code in his infrastructure that he doesn't know what's going on. One of the reasons that the adapter sits next to the database is because some database product require persistent connection, and therefore it needs to be close to the database. It also needs to be stateless, so we can scale it as much as we need. And since it's on the customer side, we want to reduce the maintenance as much and the maintenance overhead as much as we can. So we want it to be basically seamless. One of the other point is the cost, since we need to consider two different aspects. One of them is idle cost, the price that the customer will pay if there is nothing happening, and also the transaction cost. How much does it going to cost the customer in case there is a call to the adapter or the database. We consider our customers, some of them are really on early stages of the development process, and they have low traffic, but still needs to have the site fully available at all time without paying the startup time of the container. As for the database, we want to support many products. We already support some of them, and we keep adding more and more. And now I will hand over the stage to Shachar, so that so she can explain how she helped us to find the best solution within AWS.
Hello, everyone. My name is Shahar Daniel. I'm an AWS Solutions Architect, and I've been working with Wix as a customer for the past couple of years. I've been helping them architect their AWS environments for performance, scalability, reliability, operational efficiency, and of course, security. When they first approached me with this use case, well, I immediately thought out in search for a serverless solution. As Noam explained, the solution is deployed within their customer's AWS environment. We were looking for something that it is easily to create and hardly no maintenance at all. So serverless was a good fit. They also have a containerized distribution. So I immediately started with our Fargate container services. This obviously takes away the effort in maintaining infrastructure, and it can serve their deployment. The thing is, once we started, we realized we don't have immediate support for load balancing. It requires provisioning additional resources such as application load balancer, and also to have TLS support, it would require using ACM, Amazon Certificate Manager, and that means more things to control, more configuration. So you have everything that is capable to serve the deployment, and it works, but it has more effort in configuration. So the added control wasn't needed here. Also, having an application load balancers means extra cost in idle time, which is something that Wix were looking to minimize for their customers. So we continued and went over to another option. I suggested using AWS Lambda as a serverless option and API gateway to give the endpoint for the users. Here we actually got no idle cost, which is great. We've got TLS support out of the box using API gateway. However, that meant that Wix had to maintain separate code base specifically for this, for Lambda and API gateway, for this deployment. That means that every connector, they would need to create another copy of their source code. They have many databases and actually container connectors for additional resources. So to avoid that duplication and really have a standard containerized distribution, I moved on and continued to search. And that's when I offered AWS App Runner, which was just released. I immediately turned over to Wix and offered that as a service. And from here, I let Noam tell you what he was thinking about his experience with AWS App Runner. Thank you.
So once we started working with App Runner, all the pieces fell into place. It gave us a very simple deployment process. We uploaded our Docker image to ECR. With the deployment, we got a URL that we could configure our system, and it also gave us TLS out of the box without the need to configure anything else. The cost was within range for idle cost and cost per transaction. And the provision process was simple enough for automated tools and also for manual explanation. Right now, we give our customer a manual process that they need to go through a doc, but in the near future, we'll support fully automated deployment script, so the user will have just a one-click button and receive a fully working DB and adapter without the need to do anything. And after this whole long preview, I want to share with you a live presentation of the product, so you will understand what we accomplished. And before we start the demo, I would just want to review what we're going to do in the demo. So the first thing, we'll review the deployment of AWS, how it looks like. Afterward, I will quickly show how is the current Wix data solution works, and after that, we will look at the current external DB integration solution. But before we start, let's remember how it looks like. So we have an adapter, a database, and this is the things that we configure. So let's start the demo. So first, let's look at our AWS configuration. The first thing that we see now is that we have a Postgres database installed. Its name, this is the name of it, and we already defined it. It's a Postgres SQL database, and the other section of it would be the adapter. So let's go to UpRunner. As you can see, I have pre-configured an adapter. It's running. It has a configuration of it knows it will talk with a Postgres database, but also let's look at the console that we have, which is this URL. Now that we press on it, we can see that database is connected properly and it's configured to work with the same instance with some of the credentials. Now let's take a look at Wix data solution. So we'll go to the editor, and right now we have this section of the site. It shows the categories of something within the database. So let's look at the database. The database here that we look, it's industries categories. We can take a look into the data, and the data is right now, as you can see, we have retail, security, food. Let's change one of them just so we'll see it's updated automatically. I've updated the item. Now if we'll go and see the preview, we can see that it's updated. So this repeater retrieved the data and shows it to the customer. This is how Wix data works, and this is how we communicate with the data. But now we want to configure an external database. So let's go to databases. Let's press here and add an external collection. It needs to have two different parameters. One of them is the URL that was so important for us in the previous stage. We'll take it from here. And the other one is the API key or the secret. It's already configured, it's randomized. I'll just copy paste it here. And now if we edit, we can see the demo data that I already pre-prepared on the database. As we can see here, it looks exactly the same, AWS demo. It has one table, and if we look at it, this is the data that we have within it. So I have some title 1 to 4 and numbers 1 to 4. I've already connected it on another repeater, which sits right next to it. As you can see, it's connected to our AWS demo table. And now if we press preview, we can see how the external database works exactly as the same as Wix data. Let's change the data just to make sure it happens. So we're going to go to this and going to change some title 1 to something else. Now it's being saved to the database within AWS. Now I'm going to press preview again just to see the site again, and we can see, you can see that it changed as well. So this is currently the whole solution that we worked on, and this concludes the demo. Just before we say goodbye, and if you're interested to see more of what you can do, you can always look at our public and Git repo. It's already public. I've shared with you the URL and also additional resources on how to define it on your Wix site. And with this, I can conclude the presentation. Thank you, everyone,